Okay guys, so we're back again today, and this time we're going to be talking about volume. Specifically in this video, we're going to be talking about volume of a cylinder. Now to do this, we're going to have to define a few things. First, we're going to have to define volume, then we're going to have to define cylinder. So, when we're talking about volume, we're talking about 3D objects. And 3D objects, we'll use a purple marker for this one, are things that have dimension. Things that we see in our real, everyday lives. Things with multiple planes. A good way to think about something that's 3D, that has a volume that could be found, is that you can pick a point, let's say this point, and we can draw 3 lines from that point. It's 1, 2, 3. We can draw 3 lines. We know this is a 3D object, whereas with a plane, we could only draw 2 lines. So if we were talking about just a normal square here, we could pick a point, and we can only draw 1, 2 lines from that corner, okay? So this one here, this is our 3D object. This one's not a 3D object. And 3D objects have volume. Volume is simply defined as something that has a capacity to hold things inside of it. So it's got a capacity that we can deal with. It can hold things, it's got space inside, okay? And today we're going to be talking about cylinders. Now, typically when we think of cylinders, most people think of something a little bit like this. Okay? That's what we usually think of when we think of a cylinder, something kind of like a soup can. But we need to remember that this is not the only cylinder we can use. Did you know this is also a cylinder? That's because a cylinder is defined as something that has 2 congruent parallel faces that are called bases. So one base here, one base here, one base here, one base here. And they're connected or joined by corresponding points that are also parallel. So parallel lines. So here we've got a parallel line, parallel line. We've got parallel lines here connecting these. These are both defined as cylinders. And you could have even a cylinder that maybe looks like this. Anything that's got those 2 bases that are congruent and then these parallel lines. We're going to talk today specifically about how to find the typical cylinder, okay? But it can apply to any one of these cylinders. Now, when we're talking about finding the volume of one of these cylinders, we have to go back and remember a little bit about how to find area. We're going to go right back to that home base we were originally talking about. When we're talking about cylinders, though, we're going to think of our cylinder as always being our home base for finding volume. So if we want to find the volume of this, we first want to think about how are we going to find the area of one of these bases. Well, we know from our last video that when we're finding the base of when we're finding the area of a circle, we use pi r squared, okay? So we know that to find this top part here, we've got pi r squared. And some of you might remember that to find volume, usually we think of this volume as length times width times height. So length times width, really, is talking about the area of this circle up here. We just called width height last time, okay? But this is really length times width that we're finding up here. So this portion right here refers to this portion. Then, to find this height, this is going to count as our height right here. So if we want to find length times width, times, we add our h in here for height, this is going to be our volume formula for a cylinder. Okay? This is our volume of a cylinder. You've got your length times width right here. You've got your height right here. Length times width times height equals volume of a cylinder.